Good morning, one and all. Today we are discussing about basic geotechnical engineering 18Cv54 for 5th semester module 1 and lecture series 7. This particular lecture series is planning to cover sinkage limit, activity of clay, plasticity chart. So sinkage limit is defined as the water content at which further reduction of water content will not cause applicable reduction in the volume of the soil sample is called sinkage limit. The sinkage limit is given by formula water content W minus V1 minus V2 divided by WS into gamma W into 100, where W is water content in percentage, V1 is initial volume of soil in centimeter cube, V2 is the final volume of dry soil pad indirectly obtained from the mercury immersion technique in centimeter cube. WS is a dry weight of soil pad in grams and gamma W is unit weight of water in gram per centimeter cube. So in order to conduct this test, we have to use the following procedure as per IS 2720. So part 2 guidelines. You have to take a sinkage cup and you take the empty weight of the cup, that is W1 grams. To that you have to add the soil which we are used for liquid limit and plastic limit test only. So for example, red earth you are used for liquid limit test, plastic limit test also we have to use red earth, and sinkage limit test also we have to use red earth. So take that soil, 30 grams of that soil, add water which is more than 10% more than liquid limit consistency, prepare a paste and take a sinkage cup, smear the oil or grease to the inner periphery of the cup and take transfer that soil into that cup and tamp it so that air bubble will be removed, and then take the weight, let it be W2 grams. Next, keep that soil pad with that dry wet soil pad with that cup in a air drying purpose for 1 day. Next day come and observe. If any multiple cracks are observed, then the air has not released from the sample preparation, then you have to discard the test and you have to prepare a new pad. Suppose if no cracks are observed on the surface of the soil pad and only the detachment of the wet soil pad from the surrounding has taken place, then it is ready for keeping inside the that is the oven for another 24 hours. Afterwards, take out that cup and take the weight, let it be W3 grams. Next, water content W2 is equal to, so weight of water to the weight of soil particle, that is W2 minus W3 divided by W3 minus W1 into 100. So once you get that one, next to take out that dry soil pad and take a sinkage cup, fill the sinkage cup with the mercury, press the prong, excess mercury is removed, and whatever the cup with mercury is remaining, take that weight, let it be W4 grams. Then weight of mercury, so in the cup, which is equal to the full the volume of that cup is given by W4 minus W1, and volume V1 of the wet soil part, or that is equal to V1 of the volume of the full mercury is given by the weight of the soil in the sinkage cup full divided by the density of the mercury. The density of the mercury is 13.6. So if you do it, you will get the volume V1. Next, remove that mercury and take a sinkage cup, again fill it back the mercury, excess mercury by using prongs you remove it, and keep that cup with the mercury on a plate and take the soil pad, place it over that mercury and press it. So as we are showing here, so press it. Once you press it, due to the buoyancy effect, due to immersion of that soil pad, the mercury will be spilled out here. Once it is spilled out, so what you have to do is, whatever the mercury which is left out in the sinkage cup, that you transfer it back into the can, and whatever mercury which is collected here, that you transfer it on the sinkage cup, take its weight, let it be W5 grams. Then weight of mercury which is displaced due to the immersion of dry soil pad is given by WD dry, which is equal to, so W4 minus W1. Then volume of the mercury, so which is that is spilled out due to immersion of dry soil pad, which is equal to dry volume of soil pad, which is given by V2, which is equal to W5 minus W1 divided by density of mercury, that is 13.6. If you do it, you will get V2. Next is, so you have to calculate WS. WS stands for dry weight of soil fat. Dry weight of soil fat is W3 minus W1. If you do it, you will get WS. And gamma W is density of water, that is 1 gram per cc. So that you have to take it, and if you multiply it, you will get the shrinkage limit. And plasticity chart is obtained by liquid limit versus plasticity index. Plasticity index is liquid limit minus plastic limit, and so you have to plot a line by knowing liquid limit, that is 0.73 WL minus 20. Any above A line is that is clay, below A line is silt or organic soil, and from 0 to 35 you have to mark one line, that is called lower compressibility. 35 to 50 is intermediate compressibility. 50 to greater than 50 is higher compressibility. So classification of the soil is, if your liquid limit is below 35 and plasticity index, that is liquid limit and plastic limit, is above the A line, then you have to classify this soil as clay of lower compressibility. If your liquid limit is below 35 but your plasticity index is falling below the A line, then you have to call it as the organic soil or silt of lower compressibility. Now question is how to classify whether it is organic soil or silt. So once if it is below the A line, take a 25 grams of soil, heat it. After heating, you for a period of 30 minutes, you take the weight. That is, the difference of the two weight is more than 25%. Then you have to call it as organic soil. If not, you have to call it as silty soil. Similarly, if a soil falls with a liquid limit anywhere between 35 to 50, but plasticity index is liquid limit minus plastic limit is above the A line, you call it as clay of intermediate compressibility. Below the A line, if it falls, call it as silt or organic soil of intermediate compressibility. Similarly, if your liquid limit is greater than 50, but liquid limit minus plastic limit, for example, your liquid limit is 60, whereas plastic limit is 20, then plasticity index is 60 minus 20, that is 40. So 40 if you draw it, and the liquid limit 60 and plasticity index 40 if you draw, if falls in this below the A line, then you have to classify that soil as the silt soil of higher compressibility or organic soil of higher compressibility. Likewise, for classification of soil, we are using this plasticity chart. Next, activity of the clay. So sensitivity and activity of the clay indicates the history of the compacted as well as consolidated, that is clay. So now what is meant by activity of the clay? Activity of the soil is the ratio of plasticity index and the percentage of clay fraction minus 2 micron size. So A is represented by activity of the clay, which is IP by IF, where IP is plasticity index, F is the clay fraction. Suppose if your sensitivity is 1 to 4, then classification of soil is a normal soil. 4 to 8 it is a sensitive soil. 8 to 15 extra sensitive. Greater than 15 is a thick soil. So if it is above 4, you should be carefully, you have to do some chemical stabilization, then only you have to use it for ground condition, for construction of any structure. Then we have to discuss about thixotropy of the clay. What is meant by thixotropy? It is defined as a ratio of unconfined compressive strength of undisturbed soil specimen to its remolded soil specimen. So that is S is equal to Q of UDS divided by Q of remolded. So you please go through the MCQ questions which are uploaded in LMS software, and if you have any doubt, we will discuss it in the next class. Thank you for attending the class.